So hey guys, so for this video what we're going to be doing is we're going to be finding the density of a metal using a known atomic radius and the type of unit cell that the metal is packed in. So if I give you the data that magnesium has 4 atoms per cube or per unit cell, I also give you the data that the atomic radius of magnesium is 1.73 angstroms. I need to know the density of magnesium. So what I did here is I started off with the equation that tells me the edge length, which is A, of a unit cell, and this is specific to the unit cell of face-centered. So if I tell you, you have to know whether or not it's primitive, face-center, or body center. Primitive has 1 atom per cell, face center has 4, body center has 2. So since it's 4 atoms, I use the face center equation. So I just plugged in the number 2 times 1.73 times 10 to the negative 10, right, times the square root of 2. And if you go ahead and type that into a calculator, you get 4.89 times 10 to the negative 10 is that number. So with that information, that is the length of the edge of the cube. Remember, a cube is a 3D type thing, right? We only calculated the edge of 1. So in order to get a volume, by the way, let's go back. We're going to dip back into Gen Chem 1. Going to dip back into Gen Chem 1. And with this, in order to do a density, you're going to have to not only know mass, you're going to have to know volume. So that's why we need to get the volume of this unit cell. So I'm going to have to do what to this number? I'm going to have to cube it. So the volume of the cube is going to equal 4.89 times 10 to the negative 10 to the power of 3. To do that in a calculator, let me see. I got 1.17 times 10 to the negative 28. So that unit is going to be in meters to the power of 3, right? So I don't need it to be in meters to the power of 3. My final answer should be in grams per centimeter cubed. So how do I turn this into centimeters cubed? Well, 1 meter has 100 centimeters. That will take care of one of these. I need to do it again, and that would take care of one more of these, right? And then you have to do it one more time because it's in the 3rd dimension. So all the meters are now taken care of. So you take this number and you essentially multiply it by 100 times 100 times 100. You essentially get 1.17 times 10 to the negative 22 centimeters cubed. All right. So we have our volume, but how do we get the mass? What is the weight of the cube? The cube only has 4 magnesium atoms. So I just need to find out how much 4 magnesium atoms weigh. So I'm given 4 atoms of magnesium. I need to turn it to grams. So how do you turn atoms to grams? You can't go directly, you have to use the moles, right? So I need to say that there are 6.022 times 10 to the 23rd atoms per 1 mole. Now I'm in moles. I'm in the unit of moles, which is great, but that doesn't help me all the way. I need to turn moles into grams. How do I do that? With a periodic table. And magnesium has a molar mass of 24.305. So 1 mole of magnesium is 24.305 grams. So that's how you find the mass of 4 individual atoms. It's going to be a small number, right? 4 atoms does not weigh a lot. So 4 divided by, and since we're dividing by, 4 divided by a big number, 6.02 times 10 to the 23rd. It's going to be a very small number as the result, and then we multiply that by 24.305. We get a mass of only 4 atoms is 1.61 times 10 to the negative 22 grams. So my unit of grams, my unit of centimeter cubed, so all I have to do is put one over the other. So 1.61 times 10 to the negative 22 grams divided by 1.17 times 10 to the negative 22 centimeters cubed. So we type that out in our calculator. I get a density of 1.37 grams per centimeter cubed. That's how you use that data to determine density. Now, clearly, magnesium's more dense than this, so it must not actually be 4 atoms per cube, right? This must be some kind of different arrangement. So this was just a sample so that you could follow along and interpret it your own way. So the cautionary tales here is that when I give you 4 atoms, 2 atoms, or 1 atom, you have to be able to determine, is it primitive, is it face-centered, or is it body-centered? Then use the appropriate edge length equation. Once you have an edge length, you can then extrapolate and find the volume of your unit cell. Once you find the volume of your unit cell, make sure it's in centimeters cubed. Next, to find the mass of atoms. So 4 atoms of magnesium, you can't go from atoms to grams right away. You have to go from atoms to moles, and then you can go to grams. Find the grams, and then grams per centimeter cubed, and then you're home. All right, good luck, guys.